When hurricane winds tear through modern neighbourhoods, the failure often begins at the roof. Shingles peel, nails withdraw, and once wind gets underneath, entire sections lift away in seconds. This pattern feels like a modern problem, yet medieval builders faced wind forces just as unforgiving along the Atlantic coasts of Europe, the North Sea, and the Bay of Biscay. Their response was not stronger nails or lighter materials, but fundamentally different roof geometry and attachment logic. Many medieval roof systems were designed to survive centuries of storms without replacement, and some of those structures are still standing today. Understanding why they endure reveals, some uncomfortable truths about how modern roofing really prioritizes speed and cost over aerodynamic survival. Why medieval builders designed roofs to shed wind rather than, resist it. Medieval builders did not believe a roof should fight the wind head-on. They assumed wind would win if given leverage. Instead, roofs were shaped to deny wind a grip. Steep pitches, smooth planes, and continuous weight distribution were deliberate choices. You see, a medieval roof was meant to let wind slide past rather than lift upward. This contrasts sharply with modern shingle roofs, which present countless edges for wind to exploit. Once airflow gets under a single shingle, the system begins to unzip itself. How steep pitch changed everything about wind behavior. Many medieval roofs were far steeper than what we see in modern residential buildings, often exceeding 45 degrees. And, this wasn't just about shedding snow. There was more to it than that. A steep pitch actually forces the wind upward and away, which reduces uplift pressure. In hurricane conditions, shallow roofs can behave a bit like wings generating lift instead of deflecting the wind. Quite a difference, really. Medieval roofs, you see, behaved much more like cliffs. The wind was redirected, not captured. That's actually why, in coastal regions, medieval churches, barns and halls often lose their walls before their roofs. Fascinating, isn't it? The roof stayed put because its shape denied wind leverage. Why did heavy roofing materials improve survival rather than increasing risk? It's actually because the added weight helped anchor the roof in place, making it much less likely to be torn away by strong winds. Medieval roofs really relied on mass. Stone tiles, thick clay pantiles, heavy wooden shingles, and even sod were used, depending on the region. So, modern thinking assumes lighter is safer, but the thing is, lighter materials actually need perfect attachment to survive uplift. It's a bit counterintuitive, isn't it? Medieval builders really understood how to use gravity as a structural ally. A heavy roof needed far more force to lift. And when you combine that with a steep pitch, that kind of force just rarely developed. Even when individual tiles shifted, the whole system didn't just cascade into failure the way modern shingles do. It's quite remarkable, really. Now, let's talk about how interlocking tiles prevented progressive collapse. You see, by fitting together so snugly, these tiles made it much harder for a single failure to spread across the whole roof. Medieval tiles were rarely independent elements. Clay pantiles, stone slates and wooden shingles were overlapped deeply and quite often hooked or pegged into battens. This careful arrangement really boosted the strength and durability of the roof. This created redundancy. If one tile failed, those around it remained locked, so the roof as a whole stayed intact, even when a bit of damage occurred here or there. So, modern shingles, they really depend on adhesive strips and nails to stay in place. But once just a few of those fail, wind can quickly find those weak spots and, well, make things a lot worse in no time. Medieval roofing systems, on the other hand, were built with the idea that some parts might fail. They were cleverly designed to keep any damage contained, rather than letting it spread and get out of hand. There's a reason why medieval roof frames acted as unified structures. It's all about their design and, honestly, the way every piece worked together to support the whole, making them remarkably resilient. The roof was not treated as a skin laid over a house. It was, in fact, a structural system. Massive timber trusses were pegged, braced and locked together, transferring loads evenly into thick walls. Wind loads were distributed across the entire frame rather than concentrated at nail points. Modern roofs often rely on thin trusses and metal connectors optimized for vertical loads. Under hurricane uplift, these systems experience sudden, uneven stress that leads to catastrophic separation. So, one thing to note is how low overhangs reduced wind intrusion. It's quite clever, really, how these subtle design choices made such a difference. Many medieval roofs had minimal eaves. This reduced the amount of surface wind could grab underneath the roof edge, making the buildings much more resilient. Modern homes often feature generous overhangs that, well, become wind scoops during storms. Medieval builders avoided this vulnerability, especially in exposed regions, showing just how thoughtful their designs were. The roof terminated close to the wall, denying wind an entry point. This single choice dramatically reduced uplift potential. How these designs performed repeatedly under real storms. The survival record speaks clearly. Medieval coastal structures in places like Brittany, Western Ireland and the Baltic endured centuries of Atlantic storms without modern reinforcements. Repairs were, localized and incremental. Entire roof failures were really quite rare. By contrast, modern neighbourhoods often lose, large sections of roofing in a single event, even when built to code. The difference isn't materials science, it's design philosophy. So, how can modern builders apply medieval principles today? So, the lesson here isn't to, abandon modern materials altogether, but rather to apply medieval logic to our designs. Steeper roof pitches, for instance, help reduce uplift. And, heavier roofing systems, as long as they're properly supported, tend to resist failure better than those lightweight skins. Oh, and let's not forget, interlocking materials really do outperform ones that are just independent. By reducing overhangs and sealing roof edges, we effectively deny wind any access, which is, honestly, a simple but crucial step. Most importantly, roofs really ought to be treated as structural systems, not just decorative layers sitting on top. That's, I think, the key takeaway here. You know, these steps really do echo medieval practice, and they've actually already been adopted, quite quietly, in some hurricane-resistant designs. So, why did medieval roofs assume maintenance rather than replacement? Well, that's a good question. Medieval builders, they expected roofs to last for generations, not just for warranty cycles. Tiles were replaced one by one, and timbers, well, those were repaired, not simply discarded. This mindset created systems that failed gracefully rather than suddenly. Modern roofing often assumes full replacement after failure, which, you know, incentivizes designs that prioritize speed of installation over resilience. Why this knowledge still matters, you know. It's not just about looking back, but about understanding why these lessons are, well, still so relevant today. As storms grow more intense and rebuilding costs rise, revisiting proven historical solutions becomes, honestly, practical rather than nostalgic. Medieval roof designs were not accidents of tradition. They were, in fact, responses to environmental reality, refined through trial, error, and survival. They teach that resisting nature is really less effective than shaping structures to coexist with it. For those who value historical engineering that still outperforms modern shortcuts, this is exactly the kind of insight Relic Logic exists to share. Subscribe to the channel for more deep explorations into forgotten building knowledge and, well, share this episode with anyone who believes the past still holds answers for the storms ahead.